In this video, we're going to talk about evaluating and graphing piecewise functions. A piecewise function is a function that is represented by a combination of equations that each of those equations corresponds to a part of the domain. For example, here we have the function f of x is equal to the first equation. It would be equal to x if x is greater than 0. It would be equal to negative 2x if x is less than or equal to 0. So, for example, if I were to pick the number, let's say I would pick the number 5. Then I'm going to plug that into my first equation. So if x is 5, then y would also be 5. So my first point on the coordinate grid where I would have x and f of x would mean that I've plugged in the number 5 for x, and so I need to use my first equation, and so that also means that my y value, or f of x, is 5. And I can continue with a table from there. In my other equation for the same function, if I have my x and my f of x, my domain, or my input values, have to be less than 0, or equal to. So if I were to use 0 as my first value, I would then plug that into my equation. Negative 2 times 0, that means my f of x or y is 0. I would pick another value less than or equal to 0, might be negative 1. So if I plug that into the equation, negative 2 times negative 1 would give me a positive 2. And I would continue with my table from there. So let's do a little bit more practicing with evaluating piecewise functions. So I want to find f of 0. So that means I want to use my input, or my x value, to be 0. So let's take a look at my two domains. The first domain says any values that are less than or equal to 3. My second part of the domain is if x is greater than 3. So that means since 0 satisfies this part of the domain, I'm going to plug 0 into the first equation. So 3 times 0 is 0, plus 2. That means that my f of x is 2. Now I'm going to take the number 3, and I'm going to use that as my domain. So again, looking at this first domain, x is less than or equal to 3, so since I'm going to use exactly the number 3, I'm going to plug that into that first equation. So 3 times 3 is 9, plus 2 means that that one is 11. Now I want to evaluate with the number 6. Now I will use the second equation because my domain is x is greater than 3, and 6 falls into that section. So I'm going to plug 6 right into here, and 6 minus 1 is going to equal 5. So that's going to be my f of x for that particular value. Now that we've practiced evaluating functions, we want to graph. So when we graph a piecewise function, we need to set up a table of values for each of the equations and use the domain for each of those. So I'm going to start with the value x is greater than 2. Well, that means that my value can't be 2, but we're actually going to put that into the table to start with to see what my boundary will be. So if I plug 2 into the equation, 3 times 2 is 6, and 6 minus 4 is 2. So I am not equal to 2, but at the point 2, 2, I want to make an open circle at that point to show that that's the beginning part of my piecewise function. Now I'm going to make a couple values that are larger than 2. So let's say I use 3 and 4. So I'm going to take the number 3, I'm going to plug it into my equation. 3 times 3 is 9, and 9 minus 4 would be 5. I'm also going to use 4 as part of my domain. So 3 times 4 is 12, and 12 minus 4 would be 8. So now I'm going to plot those 2 points onto my coordinate plane. So I have 3, 5. I'm just going to make a dot right there so I can draw my line in just a moment. And then I have 4, 8. So I'll put my dot there. Okay, then I'm not going to actually draw, since we have an open circle, I'll start there and then I'm going to draw up with arrow on the end to show that it would go to infinity going in that direction. Now I need to make a second table of values. I have x and I have f of x. This time my value can be exactly 2. So I'm going to use 2, and then my other x values need to be smaller. So I'm going to continue with a couple of other points, 1 and 0. So I'm going to plug in the number 2 into this equation for this part of the function. So when I put 2 in here, that changes it to a negative 2 plus 1 would be negative 1. Then I'm going to plug in the number 1. So negative 1 plus 1 would give me 0. And then I'm going to substitute 0 in here. And then 0 plus 1 would be 1. So I'm going to graph these values. This time if my x value is 2 and my y value is at negative 1, it's a closed circle because it is equal to. Then I'm going to use the value 1, 0 and 0, 1. And I'll start drawing at my end point, this time going with my values in this direction. Please make sure to put an arrow on that end showing it would go to the left, infinity. So again, the importance of my first equation and this part of the piecewise function, x is greater than 2, so I'm going to use an open circle and then I'm going to draw to the right as my x values increase. In this part of the function, it's x is less than or equal to 2 for my domain, so I have a filled in circle where my x value is 2, and then as my x values decrease, I'm drawing then to the left. I'd like to also show you a shortcut, so you can make tables of values for each equation, satisfying each part of the domain and finding your range. The other way we could do that is simply to substitute the number 3 into our equation for x, and 3 plus 5 would equal 8. So my first value that I'm going to put on here is 3, 8. And I'm going to put a solid circle at 3, 8 because it is less than or equal to. Then the interesting part is that we could look at the slope of this particular equation, and the slope m is equal to 1. So as my x values decrease or get smaller, I can then use a slope of 1, which is positive 1. Now that would be up 1 and over 1, but because our x values are decreasing, we're actually going to go backwards, but slowing a positive slope. So as our x values are decreasing, we do want a positive slope of 1. Well, let's check a value to make sure. So if my x value were a positive 2 and I were plugging that in, I would have 2 plus 5, which would be 7, and that would be right here at this particular point. Now let's take a look at this one. If our x value has to be greater than 3, let's plug the number 3 though into this equation to find our endpoint or our boundary. 3 times 2 is 6, and 6 minus 1 is 5. So we're going to find the point 3, positive 5, and that's my boundary or my endpoint. However, since it's greater than, that means we want to draw an open circle at that particular point. And then once we have that open circle, we can take a look and see that for this particular equation, the slope is 2, which would mean 2 over 1, which is positive. So from here, if we go up 2 and over 1, that's where my next value would be. And again, up 2 and over 1. So then we would draw in our line, but remembering that that particular endpoint needs to be an open circle to show that it is greater than 3. Well, let's check that next value just to be sure. So that would be at positive 4 for my input or my domain of my x value. So 2 times 4 is 8. 8 minus 1 is 7. And we are at 4, 7. So, ladies and gentlemen, you can decide which would be easiest for you. If you would like to make a table of values for each of the functions, each of the equations of the functions, and then graph from there, you certainly can. Or if you'd simply like to graph the endpoints and then use the slope of the equation to find the rest of your points and draw your line, that's great too. Remembering, please, that if you have a less than or a greater than symbols, that's where we're going to use that open circle. And if we have our greater than or equal to or our less than or equal to, that's where we're going to use our closed circle. So please be careful of your endpoints. Next, we'd like to take a look at this particular function. Now, if you'll notice that we have some number values, so it says f of x is equal to 1, or 2, or 3, or 4. Remember that f of x is simply function notation. You could substitute y equal to 1, or y equal to 2, 3, or 4. And if you remember, y equal to 1 is a horizontal line. So what that tells me in a piecewise function, that I am going to limit my domain to these particular x values, but my y at those values must be 1. So I'm going to have a horizontal line that goes from negative 4 to negative 3. So I have filled in a solid filled-in circle at negative 4 and an open circle at negative 3, and I've shaded in between to show that my domain or my x values range from negative 4 to less than negative 3. Likewise, I'm going to do the same thing where my y value is at a positive 2, meaning a horizontal line on the 2. But I'm going to go on a domain of negative 3 to negative 2. I have a filled-in circle at negative 3, an open circle at negative 2, and I've shaded in between to show that my domain ranges from negative 3 to negative 2. I'll do the same at my y value or my f of x function equaling 3 as well as equaling 4. So on the line y is equal to 3, I have a filled-in circle at negative 2, an open circle at negative 1, and shaded in between. And at f of x is equal to 4, I have a filled-in circle at negative 1, an open circle at 0, and filled in between. This particular function is called a step function because the graph of this piecewise function resembles a set of stair steps. So let's review. When you are graphing a piecewise function, you need to take a look at the domain, make a table of values, and find points for each part of the piecewise function, and then graph, remembering to watch the endpoints if you need an open or a closed circle. Ladies and gentlemen, you could also graph the endpoint of each part of the piecewise function, and then use the slope of each equation to finish off graphing. Please continue by filling out your reflection.